In this session, we'll take a look at another statistic that is used to describe variability, that is quartile deviation. Along with that, I'll try to explain the concept of skewness. Let us say there is a class test. Let's say a 50-mark test. How would students usually score on a test? Well, some who would be scoring very less marks, some very high marks, but most of the students would be clustered around the mean value, and the representative curve would be like this. Now let's say, for example, the mean value in this situation was let's say 30 marks. So what you have is the dotted line that you see in the center is the mean, so the score of 30 at the center, and most of the students around 20 marks and 40 marks all clustered around the mean value. Still, there would be a couple of students who have scored more than 40, one or two students who've reached 48 or 49, and maybe a couple of students who scored 18 or 19 marks. But the typical values would be clustered around the mean. Now, another situation that we have is a very easy test. All the questions on the test are very easy. What is the result? Everybody is scoring very high marks. Everybody is getting very high marks. So you would find all the scores that are piled up towards the right hand side of the curve. However, there will still be students who would be scoring low marks. Let's say there are a couple of students who are scoring 22 or 18, and one student who has scored still scored something like 3 marks. So because of these very few students, the tail of the curve, as it is called, gets dragged all along. That's on the left hand side. So what you have is a slope of the curve towards the left hand side. This is known as negatively skewed. You could have another situation where the test has very difficult questions. What happens with a very tough test? Everybody is scoring or is getting low marks, so you find all the scores piled up towards the left hand of the score. Still, there are those in the class, very few of them of course, who have still managed, let's say 42, or one student who has managed 48. Even under these circumstances, what happens? The tail gets dragged towards the right hand side, so the slope is on the right hand side. This is called as a positively skewed distribution. Now let's assume this test of 50 marks is given to a sample of 100 students, and as you can see from the curve, how have the questions been? Very easy ones. So all the scores, the majority of the scores, that is, are piled up on the right hand side. You will have a certain mean value, a certain median and mode value. As you can see, the top of the curve, that is where the mode lies, and the mean always gets dragged towards the tail. Always remember this: whether positively or negatively skewed, the mean is dragged towards the tail. In a normal distribution, the mean, median, mode fall on the same value. Now let us take a look at quartile deviation as to what exactly this means. I'll just put a scale there at the bottom. Let's say this is the lowest score, that is 3 marks. The score of 9 is where you find between a score of 3 and 9, 25% of the students fall over here. So out of n of 100, 25 students have scored less than 9 marks up to 3 marks. So the first 25%, as they would be, that is known as the first quartile or Q1. The next 25%, that is where you reach the value of median, 50%, that is also known as the median or the second quartile, Q2. Here the score happens to be 21. What this means is, between 21 and 9, there are 25% of students. And as you would naturally see, below the median is 50% of the population. There you can see between 21 and 9, 25%, 9 and 3, 25%. So 50% below the median. As you move ahead and you reach the score of 29, you find that again 25% of the students fall between 21 and 29. So this is the third set of 25%. This would be known as Q3, and you would have a certain highest score wherein the entire 100% of the population is covered. So you have 4 quartiles, as they are called: Q1, Q2, Q3 and Q4. Now I'll remove the curve just to remove some clutter, and what you would find is the distance between the second quartile or the median and Q1 is 12. That is 21 minus 9, 12 marks. What does that mean? These 25% of the students that you have between 21 and 9, they are spread over 12 marks. Now on the right hand side of the median, you find that this distance is barely 8 marks. 29 minus 21 is 8 marks. So between Q3 and Q2, you have 25% of the students who are spread over 8 marks. So what you find is below the median, the first quartile below the median, that is between Q1 and Q2, you have 25% of students distributed over 12 marks, and on the upper side of the median, the first 25% of cases between Q3 and Q2 and Q3, sorry, are spread over 8 marks. In a normal distribution, this would be exactly the same, but as we know, this distribution is skewed. Now, what is the average distance between median and the first quartile, median and the third quartile? This would be calculated by way of 12 plus 8 divided by 2. So what you do is basically take an average. 12 marks, the 25% cases below the median, 8 marks is 25% of the cases above the median. So you get that average, 20 divided by 2, this happens to be 10. So you could conveniently say that on an average, the middle 50% of the cases, listen to this carefully, middle 50%, that is between Q1 and Q3, 25% below the median, 25% above the median. The middle 50% of the cases around the median are distributed over a space of 10 marks on the scale. Alright, going by the formula, quartile deviation is calculated as Q3 minus Q1 upon 2. What is the value of Q3? It is 29 minus 9 is Q1 divided by 2. So again you get 20 by 2, which is equals to 10. So going by the formula, you calculate this value by 10, but you have to understand what this statistic actually means, that the two quartiles around the median value are distributed in this example by a score of 10. So you get an average of both the quartiles on either side of the median. Now this is a typical normal curve. Here we had seen 99.9% of the cases. This distribution with the help of 3SD above the mean and minus 3SD, that is 3SD below the mean, 99.9% of the cases are covered above and below the mean, both of them put together. This gives you the idea of standard deviation. While the standard deviation is calculated around the mean value, the quartile deviation is calculated around the median value. Now in this example, we have a perfectly normal distribution, hence the mean and median would fall at the same place. Now these are the middle 25% of the cases, rather the middle 50% of the cases, 25% on the left hand side, 25% on the right hand side. If you remember, in the lecture on standard deviation, we had seen the value between mean and 1 SD is 34.13. There it's written at the center. So 34.13 on either sides. What we have taken is 25 and 25 on either side. We have the middle 50% of the cases. So this middle 50% of the cases around the value of median, Q1 on one side and Q3 on one side, this will give you an idea of the quartile deviation. So what you actually do is you take an average, a mean of the distribution below the median, and above the median. So that gives you an idea of the quartile deviation around the median.